Hello everybody and welcome to Algo Expert. In this video, I'll be covering the question of first non-repeating character. Now before we dive in, let's make sure we understand what the question's asking of us and the input and output structure. So for this question, we'll be given one input. This input is going to be a string, and this string will only contain lowercase English alphabet letters. So there's only 26 possible letters that this string can contain. Any string that contains something like an exclamation point, an uppercase A, maybe an ampersand, whatever it may be, is not valid. You will only be given a string that contains lowercase English alphabet letters. What you're being asked to do is to return the index of the first character that is non-repeating in this string. A non-repeating character is simply a character that only occurs one time. If no characters in the string are non-repeating, you are asked to return -1. So for this sample input, we are asked to return 1. The reason we should return 1 is because this is the index of the first character going from the left to the right that is non-repeating. If we're looking at this string, the repeating characters in this string are A, because A occurs a second time over here at index 5, C, because C occurs a second time at index 4, and then the non-repeating characters in this string would be B, D, and F, but the reason we are returning 1 is because B is the first character that we find when traversing from left to right that is non-repeating. So that is what we are being asked to do. Now let's talk about how we can solve this problem. So I'll start by mentioning that there's many different ways to solve this problem. In this video, I'm going to show you two different methods. Now the first method I'm going to show you is kind of the brute force approach, or the naive way of solving this problem. And so let's start with that, and then we'll move into the more optimized solution. So when you look at this problem as a human, the thing you're probably doing is you're looking at maybe the first character A, and then you're scanning the rest of the string and looking for another character A. As soon as you find that, you realize, okay, this is the non-repeating character, and then you kind of move over to the next character and you do the same thing. You look for a B. Now, in this case, we don't find a B, and so that means we are good, and this is the first non-repeating character, and we would return this index. Now, this is kind of a brute force solution, right? For every character, we're looking at every other character and checking if those characters are equal to this. If we see no other character is equal to this character, and we haven't already found a non-repeating character, that means we found the first non-repeating character, and we'll return the index of whatever that character is. Now, as we saw in the sample input here, the first non-repeating character was B, because B does not exist anywhere else in the string, and well, it's the first one that we find going from left to right that is the case for. So in this solution, what we're going to do is define two iterators and kind of have a nested for loop structure. So we'll have an iterator called I, and we'll have an iterator called J. Now, I and J will initially start at 0, and then for every I, J will go through every other character in the string and see if any of these characters are equal to the current character that we are on. So we pick I equal to 0 or I equal to A, and then we check if I and J, so the characters at index I and J, are the same. Now, if these characters are the same, this means that this character is non-repeating, and so we can go ahead and continue the process and look for the next repeating character. However, if we get through all of the characters and no characters are the same, so I and J are never the same, that means that we are good and we can return that whatever index we are on is the first non-repeating character. Now, the only exception here is if I and J are on the same index. So right here, I and J are the same index. That means we are always going to have the same value. So in that situation, we will not check if I and J are the same because there's really no point in doing that. All right, so what we're going to do here is we're going to start by kind of moving J over here, and we're going to check if I and J are the same. Now, in this case, I and J are not the same, and so what we do is we move J over. We check if, again, the characters at index I and J are the same. They're not, so we move J over. Again, we continue because they're not the same. We continue because they're not the same. We get over here to index 5, and we see that the characters at I and J are the same. So now, since we have found the same character twice and I and J are not the same, what we'll do is we'll set some Boolean value equal to true, just to kind of indicate that, hey, we did actually find a duplicate. So what I'll say is duplicate is equal to, and then we'll set that equal to true, just to indicate that yes, we did indeed find that I and J were the same. And then what we would do is we would continue moving J, so now J moves over here, and now we've gotten to the end of the string, and so what we're going to do is we're going to reset J over here, but before we do that, we're going to check if this duplicate variable is equal to true. Now, duplicate is equal to true, and that means when we were checking this character at index I here, we did find that it has a duplicate. So that means this is not the first non-repeating character. And so what we'll do is we will change this back to be false now. We will now move I over by 1 because now we're going to check the next character, and now we will repeat the process. So now what we're going to do is move j again for every one of these characters. So we see that j is at 0 and I is at 1. We compare these two characters, a and b. They're not the same, and so we move j over. So j comes over here to b. Now I and j are the same index, so we don't need to bother checking, so we just move j over again. We see that b and c are not the same, so we move j over again. And we continue to move j until eventually we find something that is the same. Now, at this point in time, we get to the end of the string, so j no longer has any other values to iterate through. We see that there was no other b in this string, and we did not set this duplicate equal to false. And so we'll reset our j value back here, but now we check and we see the duplicate was equal to false. And so what we can do is actually just return the index of I to indicate that yes, we actually did find the first non-repeating character, because at index I, there was no other character that was equal to this value, which in this case was b. And we know that because we did not set duplicate equal to true. If we had found another b, we would have set duplicate equal to true, and then, well, we would have just continued the process. So anyways, that is the first solution. Now, if this was not the case, if b was not the first non-repeating character, we would just continue. So we would move I over, so I would move over here. And then we would do the same thing with j, and we would keep going until eventually we found the first non-repeating character. So that's it for solution number 1. I will clarify this in the code walkthrough and show you exactly how we implement this. But this solution runs in big O of n squared time, and we'll take big O of 1 or constant space. Now, the reason this takes big O of n squared time is because for every character in the string, we need to look through every other character. So we have n characters in our string, and for every one of those n characters, we need to look through another n characters. And so that gives us n squared. That's where we get the n squared time complexity from. We have kind of a nested for loop structure. Usually when you have a nested for loop, with a few exceptions, you're going to have an n squared time complexity if those for loops are both going through n items. Then we get big O of 1 space or constant space. The reason we get constant space is there is no extra space we need to use for this algorithm. We just need to eventually return whatever the index of the first non-repeating character is. Now, if we do get through all of these characters and we see there is no first non-repeating character, of course, we'll just return -1 to indicate that. All right, so that is going to conclude solution number 1. Now let's move on to the more optimal solution in solution number 2. So as we move on to solution number 2, I'll quickly note that in this solution, we're actually able to solve this problem in linear time, so big O of n time, while using constant space. Now, this may seem a little misleading because we are actually going to use a data structure here to help us. Specifically, we'll be using a dictionary or a hash table, whatever you'd like to refer that as. But since we know that our input is only ever going to contain at most 26 unique characters, because we know we're only going to have lowercase English alphabet letters, when we use a data structure like a hash table or like a dictionary, and we have keys associated with each of our characters, we have a finite number of keys. We have only 26 keys in total. And when we talk about big O notation, and we're talking about the space complexity here, if we have big O of 26, this really is the exact same as constant space, because any constants we don't care about, we can just cancel them out. And so that is why you're going to see here that we're able to solve this problem in constant space, is because of the fact that our input only has 26 unique characters at most. We will not be given any input that does not have 26 unique characters. Now, if we could be given any character possible, any character at all, we would not have big O of 1 or big O of constant space. Now, yes, there is a finite number of characters, but we would likely want to have another variable that denotes the number of unique characters in our string for our time complexity, or sorry, for our space complexity. Anyways, I just wanted to quickly get that out of the way because it seems a little bit misleading that I'm going to say the solution runs in constant space, even though we are using a bit of space, but that's kind of the rationale there. Regardless, let's talk about how this solution works. So the idea here is we are looking for a character that is non-repeating. So we're looking for a character that only exists one time in the string. So in order to be able to determine that, we kind of need to know how many times characters occur. And one of the easiest ways to do this is to just count the occurrences of these characters. So what we can do is set up something like a hash table, and we can make keys associated with each of our unique characters. And as I discussed, we're only going to have at most 26 keys. So we have a key A, I'll put little quotes around it, and we see that A occurs how many times? Well, it occurs 2 times in the string. So we would kind of put a 2 there. And I'll go through this more formally, but I just want to give you the idea. We'll see that B only occurs once, we'll see that C occurs twice, we'll see that D occurs once, and we'll see that F occurs once. So now we know the frequencies of all of our characters. And I'll just remove the quotes. You can kind of imagine that we do have these quoted strings here. So now that we know all of the frequencies, all we need to do is kind of loop through our string here. And at every character, check its frequency in our hash table. If the frequency is equal to 1, like in this case, when B is equal to 1, that means that this is the first non-repeating character, because it's the first character that we found that has a frequency that is equal to 1, and so we can go ahead and return that character. So again, the basic idea here is let's count how many times all of these characters exist, then let's loop through the characters from left to right, and as soon as we find a character that only occurs one time in the string, just return that because, well, that is going to be the character that is the first non-repeating character. So let's go through this more formally, and I'll show you exactly how this would work. So we're going to start by initializing kind of an empty data structure here. This will be our dictionary, our hash table, whatever you want to call it, and we can call this counts. Now what we're going to do is we're going to loop through this string here, and we will start at character A. Now, when we see character A, we'll check if this character is in the hash table. If it is not in the hash table, we'll create a new key. If it is in the hash table, we'll just increment whatever the value of that key is by 1. In this case, we see A is not in the hash table or in the dictionary, so we just insert A. We give it a frequency of 1 because, well, we found A. So our iterator, we can kind of say I was here at A, and now we've considered that, so we'll move I over here to B. So now we're on B, same thing. We're going to see is B in the hash table? No, it's not, so we'll insert key B, and then we'll give it value 1. We'll then move I over here to C. Same thing, we need to insert C, so we'll say C, give it a frequency of 1. Move over here to D. We see D is not in the hash table, so we'll insert D with a frequency of 1. Then we move over to C. C is in the hash table, so we just increment its frequency, so this now becomes 2. Then we move over to A. We see that A is in the hash table, and so we increment its frequency, so A now becomes 2. And then we move over to F. F is not in the hash table, so we give it a key of 1. So let me move that over there. And now we have figured out all of the counts of our different elements. All right, so now that we've done that, all we're going to do is loop through this string one more time. This time, when we loop through the string, what we're going to be doing is checking the frequency of these characters in the hash table. And so what we'll do again is we'll start our iterator I at A, and we will then check A in the hash table and see what its frequency is. We see the frequency is 2. That means this character does repeat, and so we move I over. We check the frequency of B. We see B occurs 1 time. That means this character does not repeat, and so all we do is return index 1, the index of the first character we found that's non-repeating. And there you go. We're done. We have finished solution number 2. Now, of course, if we make it to the very end in our second iteration here, and we see that none of these characters do not repeat, so all of them are repeating or occurring at least twice, that means that we have no non-repeating characters, and we just go ahead and return -1, and well, that concludes our algorithm. All right, so let's quickly discuss the space and time complexity of this solution. We already saw that the space complexity is going to be big O of 1, or constant space, but the time complexity is going to be big O of n. Now, the reason we get big O of n is because we do 2 n time operations. So the first n time operation, where n is the number of elements in our input string, is when we go through and create this counts data structure. To create this counts data structure costs us kind of n time, right? So I'll just do a little comment saying that costs us n. And then the second n time operation we do is when we actually loop through our string a second time and look at all of the frequencies in the counts data structure. Now that also costs us n time. And so what we get in total is n plus n. So that is equal to 2n time. When we talk about big O notation, the big O of 2n is really just n, right? Because we can remove the constants. We don't care about those in our big O analysis. And so we get our space complexity of big O of 1 and our time complexity of big O of n. Now, something to note here, you want to be careful when you declare that your space complexity is big O of 1 when you are using external space, like in this situation. Here we had a good rationale. There's only going to be at most 26 characters, so we know there'll be a finite number of keys we have in our data structure, but you'd want to really make sure you verify this with your interviewer and kind of go over what I just went over with you and describe, hey, this is the reason this is going to be constant space because I know this property about my input. Anyways, with that said, that is going to conclude this conceptual overview. Now let's move on to the code walkthrough and discuss how to implement this solution. So I'm here in my code editor, and I've got my first non-repeating character function defined, which has one input parameter called string. Now we've got 2 solutions to code out, so I'll start with solution number 1, the brute force approach, then move on to solution number 2. So the first thing I'm going to do for solution 1 is say for IDX in range, and then the len, and this will be of the string. Then what I'm going to do is define a variable. We'll call this found duplicate. And this is what we'll use to determine if we found a duplicate or not as we jump into our second for loop. So now I'm going to define the second for loop for IDX2 in range, and then this will be the len of the string. So what I'm going to do is compare IDX to IDX2. So the value at IDX to the value at IDX2. And if these values are the same and IDX is not equal to IDX2, that means I can set found duplicate equal to true. So I'm going to say if the string at IDX is equal to the string at IDX2 and IDX does not equal IDX2, then found duplicate is equal to true. Then what I'm going to do is jump outside of this nested for loop, so into the first for loop, and I'm going to check the value of found duplicate. So if not found duplicate, that means that we are good. We have found the first non-repeating character and we can return IDX. So if we did not set this equal to true, that means there was no other character with the same value. And so we return IDX. We found the index of the first non-repeating character. Otherwise, at the very end of our program here, we'll return -1, because if we never get inside of this if statement, if we never return IDX, that means there is no non-repeating characters. So as a reminder, this solution runs in big O of n to the exponent 2 n squared time, and this takes big O of 1 or constant space. All right, so that is solution number 1. I'm just going to copy this function definition here, comment this out, and now I'll move on to solution number 2. So for solution number 2, we're going to start by counting the frequencies of all of the characters. So I'll define my dictionary here. I'll say character and then frequencies like that is going to be equal to, and then an empty dictionary. Then I'm going to loop through every character in the string. So I'll say for character in string. And then what I will do is say character frequencies at character. This will create a key if it does not already exist, is equal to, and then character frequencies dot get. We'll put character here and then 0 as our default value plus 1. So what dot get will do is look in the dictionary for this key, the character key. If the character key does not exist, it will return to us 0. Otherwise, it will return to us the value associated with this character key. And then we will simply add 1 to that. So if the character does not already exist, we will then set the key. So character frequencies character is equal to 1. Otherwise, we will override the key and change it to be equal to whatever it was before, plus 1. All right, so now we have the frequencies of all of our characters in the string. So next we want to loop through the string from left to right and find any character that only occurs one time. So I'm going to say for IDX in range, and then len string, and then I'm going to say that the character is equal to, and then this will be string at IDX, and then I will check if the character frequencies at this character is equal to 1. If it is, then what I can do is simply return this IDX. Otherwise, at the end of my program, I will return -1. So again, if we never get inside of this if statement, that means we did not find any non-repeating characters. So we go ahead and return -1. So as a reminder, this solution here runs in big O of n time, and this will take big O of 1 space. Yes, we do have this data structure that we are using, but this will only contain at most 26 keys due to the fact that we know our input will only contain lowercase English alphabet letters. All right, so with that said, that is going to conclude this code walkthrough and this video. I hope you found this helpful, and I look forward to seeing you in another Algo Expert question.